Hello, and welcome to 5 Minute Math. Today we are looking at 2D and 3D shapes. This is 3.6a Readiness Practice Proficient version. If you're interested in exploring the intermediate or advanced versions for 3.6a, or for the Readiness Practice resources aligned with any other standard, you can find them by using the link in the video description. So, what we have here are we have two different sets of shapes, group 1 and group 2, that Sarah has sorted. We need to name each shape, and we need to describe two similarities between the shapes in group 1, two similarities between the shapes in group 2. All right, so let's name these. And these are all going to be three-dimensional shapes, and in fact, they are all prisms. Now, we can name these prisms by looking at their bases and what shape their bases are. So we'll start with this first one right here. And this is a rectangular prism. And I know it's a rectangular prism because I can look at the two polygons that sit across from each other, and I describe their shape. Right? So these are two rectangles that sit across from each other. They're connected by rectangles themselves, and so that is a rectangular prism. Now this is a cube, but this cube is a type of rectangular prism. And it's a special rectangular prism because its rectangular bases happen to be squares. Remember, squares are a type of rectangle. So those bases are squares. And in this last one, if we're not sure what this is, take a look at what the bases are. And the bases don't have to be sitting up and down. They can be side to side, and that's fine. So this one is sitting on one of its faces, not one of its bases. But you can see the triangles there, so that means this is a triangular prism. All right, so now we're going to look at our group 2 shapes. And let's just take a look at my base. I'll look at this one right here. 1, 2, 3, 4, 5, 6. So I have a 6-sided shape, which means it's a hexagon. So we're going to call that a hexagonal prism. And then this one is a 5-sided shape. 1, 2, 3, 4, 5, which means this is a pentagonal or a pentagon prism. Pentagonal prism. And just for continuity, let's go ahead and outline both sets of bases. And so we're looking at the bases, and that is describing the name of the prism, if it is a prism. Sometimes you can get a 3D shape that's a cone, that's a pyramid, that's not necessarily a prism. All right. And so what we need to do now is we need to, after we've named each solid, we need to describe two similarities between the shapes in group 1, two similarities between the shapes in group 2. So let's say group 1, and let's put group 2. Knowing that your answers might be different than mine, I will go ahead and put answers may vary down here, but I'll give you a few options to choose from. All right, so thinking about these shapes right here, let's see, what do we know? Well, we could describe them by, I've already started outlining their faces. So let's see how many faces we have. The thing with a prism is if you find their two bases, so let's look at my rectangular prism first. How many sides are on my rectangular prism? Well, my rectangular prism, the base itself has got 4 sides because a rectangle has 4 sides. Right here, 1, 2, 3, 4. So that means there are going to be 4 lateral faces connecting my two bases. So I've got the 4 faces, 1 for each side, connecting my two bases. My 4 plus 2 means I've got 6 faces. And I could do the same thing with my cube. I've got 2 bases that are squares, and then I've got 1, 2, 3, 4 sides. So that means there are 4 lateral faces connecting my two bases. 4 plus 2 also means 6 faces. Now my triangular prism is different because I've got my 2 bases, my 2 triangles, and then each triangle's got 3 sides. So my 3 lateral faces with my 2 bases actually make 5 faces. So if you want, you can describe this as, First off, you can say they're all prisms. If you wanted to say that, you are correct, right? You could also say they have 5 or 6 faces. Now let's see what we can say for group 2. Group 2 has got 2 hexagonal bases on the first one, and then a hexagon has got 6 sides, so there are 6 rectangular faces connecting those 2 bases. 2 plus 6 makes 8 faces. And then my pentagonal prism has got the 2 pentagon prisms, and then each pentagon has got 5 sides, so there are 5 rectangular faces connecting those 2 bases. 5 plus 2 make 7 faces. So one option for completing this problem would be to be pretty obvious. You can say group 2 is also prisms. You can say they have 7 or 8 faces. Now I can describe them in terms of faces. I can also describe them in terms of vertices. I can describe them in terms of edges. Okay, so let's look at edges here. Let's see what we've got. So my edges, I'm going to go over them in blue. I've got 1, 2, 3, 4 edges are where 2 faces meet, right? Now I've got 5, 6, 7, 8. So each face, each base is going to have 4 edges. So I've got 4 and 4 make 8, and then I've got my 4 edges connecting the 2. So 4, 8, 12. So I can say it's got 12 edges. Same thing with my cube. 1, 2, 3, 4, 5, 6, 7, 8. And then I've got the 4 lines connecting those 2. So I've also got 12 edges. Now I'm not going to get 12 edges for my rectangular or my triangular prism, but I'll get close. 1, 2, 3, 4, 5, 6, and then 7, 8, 9. You notice how I counted in groups of 4 for my rectangular prisms and groups of 3 for my triangular prisms. That's the pattern because we have triangular or rectangular bases. So I could say another option, if I didn't want to describe this in terms of faces or prisms, I could say 9 or 12 edges. And then we could do the same thing. You know, we're going to have more edges here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it's going to be hard to see, but you know there's going to be one edge for each side. So I'm going to count another group of 6. 13, 14, 15, 16, 17, 18. So I'm going to say 18 edges. With my pentagon, I'm going to count in groups of 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I can say 15 edges. And if I wanted to, I can say we have 15 or 18 edges. You can also count the vertices or the corners if you want to, but any combination of these would work to describe similarities between group 1 and group 2. For our second problem, we need to name each shape, and we need to provide check marks showing appropriate rows and columns. All right, so this is an oval. It's not a circle. It's an oval or an ellipse, if you want to get super technical. We have an isosceles trapezoid. Now, this is a trapezoid. If you just write trapezoid, that's fine. But it is a special kind of trapezoid. It's an isosceles trapezoid. All trapezoids are quadrilaterals with one set of parallel lines. So that'd be my 2 bases right here, or my 2 parallel lines. But the 2 slanted sides are the same length. So this is a normal trapezoid, probably the one we see when we're playing with pattern blocks. It's an isosceles trapezoid. This is a 1, 2, 3, 4, 5, 6. This is a hexagon. And in fact, it's actually a regular hexagon because all 6 sides are the exact same shape. So we can put those right there. Okay, so let me go ahead and just erase this, and I'll put that hexagon down there. All right. Is it a polygon? Well, a polygon is something that is closed and has straight sides. And if it is closed with straight sides, I'm going to give it a check mark. And if it's not closed with straight sides, I'm just going to leave it blank. So it is closed, my oval is closed, but it does not have straight sides. It's all actually curved, so I am not going to give it a straight a check mark. I'm actually just going to leave it blank. Now, my isosceles trapezoid it's closed, it's got straight sides. Same with my hexagon, closed, straight sides. So we're good with those. Does it have vertices? These are corners. No, it has no corners. It's all just one curved line. So my oval is not going to get any check marks in that second row, but I do have vertices here, and I do have vertices here. I've got corners. That's where the sides meet, right? So my vertices are going to be 1, 2, 3, 4. Those are my vertices. I get 1, 2, 3, 4, 5, 6. When we're dealing with polygons, the number of vertices matches the number of sides. And then, is it a quadrilateral? So this is a four-sided shape. Well, the oval has no sides, so we're just going to leave it with no check marks. My trapezoid is a quadrilateral, so it does get that third check mark, but my hexagon does not. It is a six-sided shape. So that's how we would put our check marks for problem number 2. All right. So for our third problem, we have 9 shapes here. We need to name the shape, and we need to answer some questions. So let's name this shape. This is I guess we want to call it a spiral. It's not really a shape, but it is a design that we might see. This is a cube. It's a three-dimensional shape that's got all square faces. This is a 1, 2, 3, 4, 5, 6, 7, 8. So 8-sided shape is an octagon. Now this is a trapezoid, but if you want to get technical, remember our last time we saw an isosceles trapezoid. This is different. This is a quadrilateral. It's got one pair of parallel lines, so that makes it a trapezoid, but it's got square corners or right angles. So if we want to get technical, this is actually a right trapezoid, though a trapezoid would work. This is a circle. This is not a diamond. That's not the geometric name for it. It is a quadrilateral that has 4 equal sides. So this is a rhombus. Now we've seen this before. This is a prism. Specifically, we're going to look at the shape of the two bases. It's not laying on its base, it's laying on one of its sides, but it's triangular prism. This is not a geometric shape, but it's a heart. And then this is a square. Now a square is a special type of rhombus that has not only 4 equal sides, but 4 right angles. So we've named each shape, and so we'll just put a little check mark there. I'm going to put the names in with the shapes themselves. Now, which shapes are prisms? Prisms are three-dimensional shapes, and then has 2 polygon bases. So in case we're wondering what prisms are. So which shapes are prisms? Well, obviously number 7, the triangular prism. But even though it's not in the name, a cube is also a prism because it's three-dimensional and it's got 2 square bases. So a cube is a type of rectangular prism. So we can put 2 and 7. So which shapes are quadrilaterals? That is a 4-sided shape. So not an octagon. I've got a right trapezoid. I've got a rhombus, 6, and then I've got my square, 9. So I'm going to put those right there. Which shapes are not polygons and why? Okay, so polygon is, remember, closed and straight. So since it's not polygons, let me just go ahead and write it the opposite. And that's going to give me my reason why. It's either open or curved. So which shapes are open or curved? Well, spiral is actually both. Spiral is both open and curved. My circle is closed, but it is curved, so it's not a polygon. And then my heart is closed, but it is curved, so it's also not a polygon. So I've got three not polygons that are open and curved, and we also need to think polygons are also, I'm going to put this down here, 2D. So I'm going to put 3D shapes over here. So I can also say that my cube is not a polygon because even though it's closed and it is straight, it's not two-dimensional. It's three-dimensional, and then same with my triangular prism, my 7. So I've got two different sets of shapes that are not polygons. They're either because they're open and curved or because they are three-dimensional. And then we keep coming back to 2 and 7. How are these different from the other shapes? We can say these are, you can say several things. You can say they are 3D. You can say they are solids. You could say even they are prisms. Either one of those would work. So your answers might vary on that one. If you are interested in looking at the readiness practice for 3.6a intermediate or advanced versions, or for the readiness practice aligned with any other standard, you can find them by using the link in the video description.